Okay, so this is video 2 for tonight. The last video we'll look at tonight, and this is basically the introduction to states of consciousness. So tonight we're going to look at the biological rhythms that affect consciousness, and next week we're going to look at sleep and sleep stages, talk a little bit about sleep disorders, and then we're going to look at the effects of drugs on altering consciousness. So that's the game plan. And then the week after next, which again would be November, let's see. So I got November 3rd would be next week. That's when we'll finish this chapter. So November 10th, and I think I spoke about this in the last video. November 10th, 2 weeks from tonight, will be your Unit 2 exam, and that's when you should try to have your Unit 2 lab assignment completed. All right, so let's get into biological rhythms within the chapter of states of consciousness. Here we go. All right, so the first thing we're going to do is we're going to talk about biological rhythms, what they are and what they aren't. So if you had to make a definition or define biological rhythms, they're basically periodic fluctuations in physiological functioning, which is biological functioning, that you see in humans and many other animals as well. So, for example, birds beginning a winter migration and bears going into hibernation show the influence of a yearly cycle. What we know is that the existence of these rhythms means that humans and other organisms have an internal, and you probably have heard this term before, biological clock that somehow manages the passage of time. So, in human beings, there seems to be 4 time cycles that are related to behavior. Our biological rhythms include cycles roughly corresponding to periods of a year, 28 days, 24 hours, and 90 minutes. Our yearly, monthly, and 90-minute cycles exert only a modest influence over our mental state. In contrast, our 24-hour circadian rhythm exerts considerable influence over our cycles of sleep and arousal. So the circadian rhythm is really the most influential rhythm in terms of affecting our behavior. Circadian rhythms also produce periodic variations in alertness, body temperature, hormonal secretions, and other fluctuations that have to do with biology and growth. So some of the research indicates that body temperature tends to drop as a person falls asleep and begins to ascend as a person awakes. So if you think about it, if you've ever been woken up in the middle of the night, 2 or 3 in the morning, a lot of times you wake up and you're chilled and you think the room is cold. The reality is probably the room hasn't changed temperature. The temperature that's dropped is the temperature within your own body. So they did some interesting studies of subjects who spent weeks living in a cave. I don't know why you would want to do that, but again, each to his own. And these people that lived in these caves were cut off from clocks and cycles of day and night. And it showed that the circadian rhythms generally persist even when all external time cues are eliminated, which is interesting. So again, it supports the idea of this internal biological clock. The thing that was interesting about some of these studies is when people are isolated in this way, they tend to drift towards a 25-hour cycle. So if you look at the chart, it plots one subject's sleep sessions. People tend to go to sleep and awaken about an hour later each day. So theorists believe that the cycle of day and night is important because exposure to sunlight readjusts our biological clocks. This readjustment may be necessary to correct for our curious tendency, like you saw in the last slide, to drift towards a 25-hour cycle. So the way we think it works is exposure to light apparently seems to affect the activity of a small structure that you might remember from the chapter that we did on biological psychology called the hypothalamus. And within the hypothalamus is another small structure called the suprachiasmatic nucleus, which seems to send signals to the nearby pineal gland, which then secretes the hormone melatonin, which seems to play a key role in adjusting our biological clock. So the reality is, no matter what chapter we talk about, it's hard to get away from biological psychology, because everything that is psychological is simultaneously also biological. Excuse the phone. Okay. So let's take a quick look at a couple of concepts that we just discussed. So if you had to click on one of the cycles that is not a human biological cycle or a human biological rhythm, which would it be? And I'm hoping you would say 6 hours. You may see a question like this on the next exam. That's why I'm doing these check your understanding components. So the correct length of a circadian rhythm, is it 90 minutes, 6 hours, 24 hours, or 28 days? It is 24 hours. Click the name of the structure in the brain that appears to house our biological clock. Is it the thalamus, hippocampus, hypothalamus, or cerebellum? It is the hypothalamus. Okay, let's move on. Let's talk a little bit about jet lag and something that some of us may have to deal with, rotating shifts. So when you get out of sync with your circadian rhythms, one of the key causes for that is something called jet lag. So when you fly across several time zones, your biological clock keeps time as usual, even though official clock time changes. You then go to sleep at the wrong time and are likely to experience difficulty falling asleep and poor quality sleep, a pattern that unfortunately may continue for many days. Among other things, the speed of the readjustment depends on whether one is flown east or west. So believe it or not, well, believe it, generally it's easier to fly westward and lengthen your day than it is to fly eastward and shorten it. So if you're flying from California to New York, you'll suffer from less jet lag than you would if you were flying from New York to California. So this east-west disparity in jet lag is sizable enough, believe it or not, to have an impact on the performance of sports teams. They have done studies, and they found that teams flying westward perform better than teams flying eastward in professional baseball. So the question is, why do people adjust more easily after flying westbound? And we think it's because flying westbound allows you to go with the natural drift towards lengthening the daily cycle. We think that flying eastbound goes against this drift, almost like swimming against a river current. Another issue that you have to take into account that can affect your sort of overall feeling and sort of balance, your circadian rhythms, are rotating work shifts. These are shifts that force people to change their sleep schedule, and because of this, it can really wreak havoc with your biological rhythms. Some of the studies that I've read show that workers get less total sleep and poorer quality sleep when they go on rotating shifts. So when we talk about firemen and many doctors in ER rooms and police officers, they tend to work in rotating shifts, and that can affect their overall well-being. There's a psychologist that studied this by the name of Charles Zeisler. He and his colleagues have shown that the negative effects of shift rotation can be reduced by using knowledge acquired in the study of these biological rhythms. And I think we're going to talk a little bit about what he found. So in their research, they demonstrated that shift rotation is less disruptive when the workers rotate through progressively later starting times. So these rotations, as opposed to progressively earlier starting times, mesh with the natural drift towards lengthening the daily cycle, which is what you want. They also showed that shift rotation is less troublesome when shift changes occur every 3 weeks instead of every week. Okay. And that is going to end tonight's video on states of consciousness and biological rhythms.